Alright everyone, so in this video we're going to be talking about repetitive structures, or how you can repeat things in MATLAB through what's called for loops or while loops. If you want to understand a breakdown of how the for loop works, you can go to help for and get a sense of this. This is just another structure that exists within MATLAB that lets you repeat things over a cycle. And you can see here, repeat specific statements over a number of times. So the general format of this is going to look very similar to the if statement. You're going to have for, and then you have some expression up here that's going to be a variable is equal to some sequence, and then end. And then you'll have an end. Then you'll have statements and you end it. So in this case, let's give an example of for n is equal to 1 to 10. Alright, and so now we're going to create this structure of this for loop. Now, in this for loop, I can say we'll have this do where count is equal to count plus 1. And I'm going to go ahead at the top of this and say count is equal to 1. And then I'm going to end. And so now we should be able to take this, 4, and I should have known that it would look weird because there was no capital, so be careful with the capitalizations. We can take this, Control C, and run it here. Let's clear, seal, and run it. And you can see it's doing exactly what we said. It's going to say for the first sequence, n is equal to 1, and so it said count is equal to count plus 1, which is now 2 because we started with count of equal to 1. And then it did it again for n is equal to 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the sequence. Well, we can change that up a bit and make it a little bit more rational, logical. For example, I can have it set an index in the count rather than have count be a rather than, I guess in this case, we can have count, and then I can create is equal to count plus 1. I can actually create a variable called tally n is equal to count. And so in this variable here, it's going to create a vector so that for the first position n, it's going to, the first index 1, it's going to equal to count, so that'll be 1. Then it's going to, count is going to be added 1 to it, so this count is going to become 2. And then in the next loop, n becomes 2, so it's going to say the second position in tally is equal to count, which is now 2, and it's going to sequence that all the way through. So if this works right, we should end up seeing a growing vector called tally that here has the numbers sequencing in a row. 1, so count is equal to 2, now tally is equal to 1, 2. This is the second iteration. Here's the third iteration. Here's the fourth, 5th, 6th, 7th, all the way down to the 10th iteration. And once it equals 10, once it does 10, count is equal to 11 now, but now the n integer, this vector here, is done, so the counting is done. Now, what's nice about this, CLC, clear. What's nice about this is n doesn't have to be a sequence of straight numbers. It could actually be a variety of different things. Now, when you do it this way, though, it becomes a little bit more tricky, but you could actually have 5, 10, and 15, and I'm just going to do it there like that. I'm no longer going to tally with n, because if I try to do it this way, it's going to say n index of 5 is equal to count. That's going to make things a little bit confused. It's not going to work as well. It should be an integer sequence if you're going to do that. But in this case, I'm just going to say n is equal to 5, 10, 15. So if I said n, and just let it count, it should just repeat what the numbers are. So here you can see n of 5 count is 2, n of 10 count is 3, n of 15 count is 4. This is, or 3 and 4. So you get a sense of how it's just sequencing through these steps. That's in a nutshell, exactly how the for loop works. And it'll just keep on going until all the numbers in that vector are exhausted, and you're done. And that's it. Now, that might seem a little, I don't know how you say, silly. Well, what can you do with that? Well, you can actually, and this is a great time to show what Meshgrid does and why we teach Meshgrid and what count does and how how you can actually do the same thing with a for loop. And it's actually a little bit more cumbersome with a for loop, but I think it's a good example of what we can do. So let's clear everything out. So if I wanted to just find, again, this is going to be the length times width example, again, just because this is, I think, will hopefully help illustrate once again the point of this. If we say length is equal to 1, 5, 10, and the widths of interest are equal to 5, 10, 15, and 20. And what we want to know is what the areas are of all combinations of lengths and widths. That is the goal here. So we could use Meshgrid, which I've already shown you how to do. However, we can also do the same thing with for loops. It's less elegant, but it will hopefully maybe wrap your head around it a little bit better. So in this case here, what we can do is create a new program, so to speak, that's going to look at and iterate through different lengths and widths. So I'm going to create really quickly vectors and variables called I and j, which are going to be the index positions for our new area array that we're going to create. But what I want to do is I want to loop through. So we're going to say loop lengths. And so I'm going to say L is equal to length. And for every length, I want that as it loops through, it's going to set length is equal to the first value in that length vector. And then I'm going to create another loop within that loop of width. And in this one, I'm going to say width is equal, W is equal to width. Now that we have those two, I can simply say our array or our area vector is going to be I comma j is equal to L times W. Now what's this going to do? What's going to happen here is, and I'll actually let it sequence through so you can see, but it's going to, as ij equals 1, for the first value, it's going to take length of 1, and then it's going to loop through all 4 widths. So it's going to say, for each one, it's going to, in the first loop in here, it's going to say 5 is times 1 times 5. And then this loop is going to go again, it's going to say 1 times 10. Then it's going to go again and say 1 times 15 and 1 times 20. Once this internal loop is done, it's going to go this loop out here, and it's going to change now this position here from 1 to 5, and then it'll cycle through these 4 again. Now, if I just say I and j here is 1, it's going to loop and copy over that same position over and over and over and over again. I don't want it to do that. Why don't I want it to do that? Well, because it's going to write over the information I want. I want these counters, the j position, to count up, to make sure it doesn't erase itself in that loop. And I'm just going to space this so it looks clean. And I'm going to hide this counter in the loop so it's a little less redundant. Now, we'll have that. Then once that loop is done, this loop is done, so the first loop is going to go through, it's going to say 1 times position 1, 1 is equal to 1 times 5. Then the second loop is going to say 1 times 10, and it's going to be 1, 2, because this j has gone to 2. Then the third time is 1, 15, and I want this to be 1 and 3. So it's going to loop there, and once it's over, I want j to reset to 1. But for the L loop, I want it to be now counting that up. And I encourage you to write through this yourself, practice this, so you can see what's going on here. And now, if I take this entire code, copy and paste it into here, you will see that you have this vector going up, creating a curve, and now it's just multiplying, as we said, making it bigger and bigger and bigger and bigger, and then the next one bigger, 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 until it finally has the entire code in place that we wanted. This is the simple process of how you can multiply 2 vectors through a looping iterative approach within MATLAB to combine 2 variables together. Now, The mesh grid, if we were to do this mesh grid approach, the way we would have done it is created a new length, comma, new width is equal to mesh grid of length, width, and then we would just say area mesh is equal to new length dot times new width. And so if I hide this, show this, we should be able to do both of these. Hit enter, and while the table is inverted, if we said area mesh, oops, here you'll see you have identical 5, 5, 10, 10, 15, 20. You obtained the exact same result in 2 lines that required this cumbersome, so to speak, looping method that you can do this. If the meshes were much larger, say 1,000 by 1,000, or your arrays are much larger, 1,000 vector long, this becomes, because it's sequential calculations, is a much slower approach than this 2-line array of solving the same problem. So this is, in a nutshell, a great illustrative way of learning how the for loop works and the mesh grid, how it relates to each other. So I think this is a wonderful example to see what you can do with a for loop and how you can do this. Now you can also envision, you can start using the for loops for things like searching. For the find command, you can actually ask it to sequentially look through an array one step at a time to see and find a number, and if it finds the number, pull it out. You can have it do iterative calculations for you. There's a lot of things you can do with the for loop that in some cases you would want to use, but oftentimes in MATLAB, because you can pretty much vectorize your code, it's much better to do it in the array form than the for loop. But it is important to know and understand where this can be useful. So I think with that, and I should say one of the best examples of this where you would use a for loop is for iterative calculations. If you do need to resort to an iterative calculation, you can use a for loop or a while loop, which we'll talk about in the next video, to find these things. So I'll give that a next example, and that'll be it. Thank you.